Hello, I'm Hoshi Yasumoto. We researched about mathematical modeling of methanol effect on the Berezov-Zalchinsky reaction. The Berezov-Zalchinsky reaction, which is called BZ reaction, is a periodic redox reaction which observed when these four types of compounds were mixed. Under the stirred condition, electrical potential as well as solution current changes periodically. Whereas in a thin layer, concentric chemical waves propagate. In the previous study done by our seniors, adding methanol shortens the oscillation period in the oscillatory regime. However, the mechanism responsible for this remained unclear. Also, BZ reaction is known to be analyzed by mathematical models. These are the principal reactions of BZ reaction. By simplifying these reactions, the oreganator is yielded. Based on the oreganator, the kinetics of the reactions is expressed like this. This kinetics is simulated by using graph like this. As you can see, the concentration oscillates over time. We aim to understand the mechanism of this phenomenon in not only experimental but also theoretical ways. In the preliminary experiment, we added methanol to the solution under the pattern-forming condition. As a result, the wavelength, which means the distance between two chemical waves, became shorter than usual. The results suggest that the velocity of chemical waves decreased by adding methanol. So, we measured the velocity of chemical waves at different concentrations of methanol. As a result, the velocity of chemical waves decreased with a higher concentration of methanol. Also, the velocity of chemical waves is expressed by this equation. These two are constant, and effect of hydrogen ion is negligible due to its weak acidity. What this means that the velocity of chemical waves depends on the concentration of bromate ion. So it is suggested that the methanol decreased the concentration of bromate ion. So we applied this result to the mathematical model and added a term for bromate ion consumption, like this. This kinetics is simulated by using graphs like this. Oscillations disappear. These simulations is significantly different from the experimental result. So we reconstruct the kinetics. Based on the two half reactions, a possible reaction is yielded. From this reaction, methanol reacts with bromate ion to form formaldehyde and bromous acid. To confirm this reaction, we conduct DNPH test. As a result, the formation of formaldehyde was confirmed, which means this reaction truly occurs in the system. We applied this reaction to the kinetics and added a term of production of bromous acid, like this. The kinetics is simulated by using graph like this. As you can see, the oscillation period was shorter than usual. Therefore, the development of the kinetics incorporating the effects of methanol reproduce the experimental result. In conclusion, methanol reacts with bromate ion to form bromous acid, which leads to the shortening of the oscillation period. Thank you.